Okay, let's do number 5, because number 5 is a little bit more complicated than the other problems. Problems 1 through 4, if you look at 1 through 4, all the vectors are given to you in rectangular coordinates. So it's pretty easy. You just add the x components and the y components, and then you convert your answers to polar coordinates. But here, the F1 and F2 are given to you in polar coordinates. So here's what's given. We know that F1 is given to be 17 newtons at 20 degrees, and F2 is given to be 20 newtons at 80 degrees. And what are we trying to find? F sub r, the resultant vector, and I want the answer in polar coordinates. So I know that FR is just the sum of F1 and F2. So F1 equals 17 newtons, 20 degrees, plus F2, 20 newtons at 80 degrees. Now, can I add these up like this? No. You cannot add vectors in polar coordinates. You just can't. I mean, you just get the wrong answer. You would get 37 newtons at 100 degrees, and yeah, you'd get that, and you would lose all the points on a quiz because it's completely wrong. By the way, a couple people did this on the adding vectors quiz. It happens every year. You know, I plead with you, please, please do not add vectors in polar coordinates. Somebody does. All right. So let's put these in rectangular coordinates so we can add them. If we want the x component, you just take the 17 newtons and multiply it by the cosine of the angle. And then you take the 17 newtons and multiply it by the sine of the angle. And here we'll do the same thing for F2. And I'll draw a picture of this to show that it makes sense. And this is just review what we've already done. Okay. Now, let's go ahead and write those out. Some people will just go here. Okay, they'll just enter that in their calculator and enter that in your calculator. And that's fine if you want to do that. You know, if you have excellent calculator skills, that's awesome. But let's just write down what these vectors are in rectangular coordinates. Did somebody do 17 times the cosine of 20?
15.97.
Yeah, 15.97. I'll take that. 20 degrees is very shallow, so I know that my x component is going to be almost as big as the actual magnitude. And then sine of 20 should be fairly small. I don't know, was it 4 or 5 newtons? What do you get for the y component here? 17 times the sine of 20. 5.81? Okay. And then let's take a look at F2. What is 20 newtons times the cosine of 80? That should be like 3 or 4.
3.47.
3.47?
Yeah.
And then 20 newtons times the cosine of, oh, I made a mistake here, huh? That should be sine. How come nobody, you know, it's a sin not to put sine here in the y component. Okay, so you need a, if I make a mistake, especially if we're recording it, would you guys like, Mr. Lake, that should be sine? Because I know some of you caught that and you didn't tell me. Okay, it's like if I was walking around class with my written down and you just let me do it all, no, you got to tell me. All right? All right. Awkward, yes, but no, it's not entertaining. It's terribly embarrassing, and I'm kind of a nerd, so I do that sort of thing. All right. 20 newtons times the sine of 80 degrees.
19.7. Yeah, 19.7.
Okay. Newtons. Now we can add them. Because F1 is pushing this hard in the x direction, and F2 is pushing this hard in the x direction, so you can just add them. I don't know. What is this? 14. 14 again. 9. What is that? 19.44 is what I get?
Yeah.
And then we'll add this 25.51 newtons.
Yeah.
Wow, I can add. And now, and that's my answer in rectangular coordinates, but of course we need to convert it. Use Pythagorean theorem, 19.44 squared plus 25.51 newtons squared. So what do you get? You get probably something like 32, 33, 32. Shall we round it off to 32? 0.07. Okay, 32. Now how do I get that? I just look, okay, I know it's going to be bigger than 25, and then I look at this one, oh, it's pretty close, so it's going to be significantly bigger than this, but, so there you go. Oh, wait, I forgot the angle, huh? So theta equals the inverse tangent of the y over the x. And then I look at, first of all, nothing's negative here, so I'm in the first quadrant. And the y value is bigger than the x value, so I know it's going to be greater than 45 degrees. 52.7. Okay. So FR, let's 32 newtons, 52.7 degrees. And let me draw a quick sketch. I go, okay, F1 was 17 at 20. And then F2 is 20, so it's a little bit longer at 80. So here's 20 degrees, and then this would be 80 degrees. And then, so this is F1 here, and here's F2. So R would look something like this. F sub R. Starts where F1 starts, ends where F2 ends. There we go. And I look at my answer, and does that make sense with it? Yeah, it looks right to me. Look, it's always good to check your work, because what if your calculator's left in radians or something, or you forgot the square root? There's a common problem. People do this, and they forget to take the square root, and so you get something that's absolutely huge. And so it's always good to look at your answer. Does that make sense? Well, to me, this all makes sense now. So that is the answer for, this is the whole thing for number 5. And there you go. Actually, let me get the whole thing in the screen here. There we go. That is all.